Hey, how's it going, geometry class? Sorry I can't be there today, but you get me in a video, which is just as good. So we are going to go through section 4.1.1 today. It doesn't take very long. I just got to teach you a couple things. We're in a triangle chapter, right? We're going to talk triangles actually for the next four chapters. Chapter 4, Chapter 5, Chapter 6, and Chapter 7 are primarily triangle related, which is super, super important in geometry. Um, Triangles, essentially, let's see, I'm hoping that I can, uh, hoping you can still see this screen, but triangles in the real world. Um, just want to show you, bridges, structures, uh, basically anything geometrically related, right, is going to start with a triangle. And the reason for that is I want to show you this too, the strength of triangles. Oh, I actually like that image. Okay, so in a triangle, if you look, all right, if you were to, in a triangle, if you were to push on the top in any way, honestly, left or right or downward, it actually like braces the force, and the triangle is actually not going to move. But in a similarly shaped square, if you apply force in either direction, the thing is very, very easily bendable. And so triangles are used in bridge building, architecture, et cetera, et cetera, et cetera. They're super important. So I'm going to teach you a little bit about them in this chapter, starting with like what types of triangles are what, like how do we, how do we classify triangles? What do we call them? So I'm going to just give you a little bit of vocab here and then talk about some angles in triangles, and we're going to call it good. So I would normally have you do all of this on Google ahead of time, but I'll go ahead and just tell you so you can write down. You pause the video as you're writing, but I'm going to define each of these for you. An acute triangle is a triangle with all acute angles. All acute angles, and it looks just like this. Right? Just draw. Um, all angles are acute inside here, right? And you can clearly see that here. Um, an obtuse triangle is a triangle with one obtuse angle. Okay, it would look like this. Okay, has clearly one obtuse angle. The other two angles would be acute, all right? Because just as a quick reminder, maybe from, yeah, I'm almost guaranteeing you know this, but all of the angles inside of a triangle have to add up to 180 degrees. So one obtuse angle is already over 90. You can't have another obtuse angle in there, and we wouldn't even form a triangle at that point. Okay, so the other two have to be acute. A right triangle is a triangle with one right angle. Okay, and it looks like so. Anytime we're drawing a right triangle, right angle. And then what's cool about the other two is the other two angles will not only be acute, but also they're going to end up being complementary with one another. They're going to end up adding to 90, those other two angles. Okay, so just wanted to quickly show you what one looks like. Put a little box in there. Um, one right angle, the other two are acute, and they'll add to 90 together, those other two angles. An equiangular triangle, it's not as common to call a triangle equiangular as it is equilateral, but an equiangular triangle is a triangle with all angles equal. And as it turns out, a triangle that's equiangular will also be equilateral, and we'll get to equilateral in a minute, but they're all going to be the same angle, so it's acute. This is also a type of an acute triangle, but even more specifically, they're all going to be 60 degrees. 60, 60, and 60, adding up to 180 degrees. Okay, so that's how we classify triangles by angle measure. It's either going to be acute, obtuse, right, and if it's a special type of acute triangle where all of them are 60, it's called an equiangular triangle. Now let's get into how we would classify triangles by side length. Okay, by side length, we can classify triangles as scalene, which means a triangle with no sides congruent. Okay, so you could have a scalene acute triangle that would look like this. Do I want to do that? No, I wanted to keep that kind of like so. Okay, all different lengths, longest, second longest, shortest-ish. Yeah, I mean, yeah. So an acute scalene triangle. Here would be an obtuse scalene triangle. It's really easy to draw. Okay, longest, second longest, shortest. You can have a scalene right triangle, like so. Okay, longest, second longest, shortest. And so any type of these triangles up here, the only thing you can't have is an acute equiangular, or excuse me, a scalene equiangular triangle, because equiangular will also be equilateral. We'll get to that in a minute. But anyways, then there's something called an isosceles triangle, which is a triangle with exactly two congruent sides. A triangle with two congruent sides. It looks kind of like an ice cream cone, which is how I remembered isosceles triangle. I was first learning this growing up. Like so. Okay, so how we know they're congruent is we'll have little tick marks here. So that would be an acute isosceles triangle. You could also have an obtuse isosceles triangle. And so we can see we can have a right isosceles triangle like this. Okay, the only thing we can't have is we cannot have an equiangular isosceles triangle, because again, if it's equiangular, it's also going to be equilateral. Speaking of equilateral, it's a triangle with all sides congruent. And those just have to be just a perfectly looking bang, 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 boom, boom, boom. Tried my best. 7, 7, 7. If it's equilateral, it's also going to be equiangular. Okay, so understand that these are how we classify triangles by both side length and angle measures. So I will ask you, I'll draw a triangle like so, and I'll have 1, 2, 3. So they're not the same. 1 tick mark, 2 tick marks, 3 tick marks. And then I'll call this 140 degrees. And I'm gonna ask, what type of triangle is this? And you're gonna say this is an obtuse scalene triangle. Okay, obtuse because of the angle measure, scalene because of the side lengths. Okay, let's talk about angle measures in a triangle for a second. A triangle's interior angle measures must add up to 180 degrees. 180 degrees. What their interior angles add up to. So if you get a triangle on your homework where that's 95 degrees and this is x and this is x plus 2, right? You're going to literally just say x plus 2 plus 95 equals 180, and then you're going to solve for x, right? That's what it'll say, solve for x in this problem. Okay, there's 2x plus 97 on that side equals 180. So 2x would equal 83, I believe. Yep. So x would equal 41.5 there, if that were your particular problem. Okay. You'll have those kind of problems today on interior angles, right? They add up to 180. Another thing you might see, by the way, is in an isosceles triangle. Okay, if these are congruent and this one is, let's call it 34 degrees, it might ask for this angle here and this angle here. Okay, well, one thing about isosceles triangles is that the angles, there's also going to be two angles that are congruent. The angles that are opposite the congruent sides, we call those base angles. We'll learn that here soon in chapter 4. But those are going to be congruent to each other. So how you'd find each of these is you'd take 180 minus 34. That would get you to 146. 146 degrees is what these two have to add up to. Both of these together have to add up to 146. And they're both the same. They're both the same exact measure. So we're just going to take that 146 divided by 2, and we're going to get 73 degrees. Each of those angles right there would be 73. So because yeah, I think you'll see a couple problems like that today too. Isosceles triangles have two congruent angles as well. Okay, now let's talk about exterior angles, right? Which was on your objective. We're going to find angles in triangles. Sorry, so it wasn't in your objective, but there is also something called an exterior angle. Now, here is an interior angle. Okay, interior angle. If I took one side, do this with me, and I extended it in one direction, okay, and I took this side and started there and extended it in one direction. I took this side and started right there and extended it in one direction. It creates kind of a cool shape. The exterior angles are these formed out here, right? It's this angle, it's that angle, it's that angle. So exterior angles are formed by taking a side and extending it in one direction. One direction, one direction. There's 3 exterior angles. The first thing I want you to know about exterior angles is what's cool about them is they don't add up to 180, but they do add up to, watch this, they do add up to 360 degrees, which is really cool. So exterior angles, first thing I want you to write down, exterior angles will always add to 360. Will add to 360 degrees. Okay, and the last thing I want you to know about exterior angles is that I'm going to draw just one exterior angle for you. Do this with me. This is angle 1 and this is angle 2. I'm going to call angle 3 here and I'm going to call angle 4 there. Okay, hopefully you agree by now that the measure of angle 1 plus the measure of angle 2 have to equal 180. They're a linear pair. So as it turns out, an interior angle and its exterior angle will be a linear pair with one another. So they add to 180. Okay. Hopefully also in this lesson you agree that the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 equal 180 degrees. Why? Because those are the 3 interior angles in our triangle. So what this means is that one exterior angle has to equal the other 2 interior angles when you add them together, right? The measure of angle 2 has to equal the measure of angle 3 plus the measure of angle 4 because they both pair with 1 to add to 180, okay? So we want to write this down. It's called the exterior angle theorem. Write this down. Last thing we will write down in this video. Exterior angle theorem. Okay, and the exterior angle theorem says the following. An exterior angle equals the sum of the other 2 interior angles. And by other 2, I mean the ones that it's not attached to. The other 2 interior angles. Okay, and so we can see it in this diagram, right? 1 plus 2 equals 180. 1 plus 3 plus 4 equals 180. Therefore, 2 and 3 plus 4 got to give us the same thing. So how you'll see that in your homework, on like a quiz or test, is this will be like 136 degrees. This will be a 2x plus 1, and this will be like I don't know, 40. And it's going to say solve for x, right? Solve for x. And what we'll do is we will say 136 has to equal 2x plus 1 plus 40, all right? So that's 2x plus 41 equals 136. Subtract the 41 from both sides, and you're going to get 2x equals 95, I believe. 95, yep. And then x would equal then 47.5 0.5 if that were the case. Okay, so an exterior angle equals the sum of the other two interior angles. That's going to do it for today. Hopefully you have a good understanding of how we classify and name triangles, interior angle information, and exterior angle information. All right, have a great weekend, guys. We'll see you Monday. Bye-bye.